All right, section 3.8 is the addition of HCl to an alkene. This is going to be our very first reaction that we're going to learn. Organic chemistry is about understanding the chemistry of carbon. And we're going to talk a lot about these chemical reactions and what carbon can do. Okay, so this is our first reaction. We're going to spend a lot of time on this for this chapter, and we'll spend a lot more time on it in chapter 4. But for right now, let's just take this reaction and talk about a mechanism. Talk about how you look at mechanisms and why we do mechanisms. Okay, so the reaction is you take ethene plus hydrochloric acid. It's going to be a addition reaction, and you get 1-chloroethane. Okay. Now, notice I am not putting the lone pairs on the chlorines anymore. At this point, we should realize that there are lone pairs on that chlorine. Okay. So, first thing, determine Lewis acid, Lewis base. Now, everything's neutrally charged, but by looking at HCl, I think you can figure out that that's a strong acid. Therefore, that's going to be our Lewis acid. Okay. This is our Lewis acid. However, let's use the new name. This is our electrophile. Okay. And then that means our double bond is our Lewis base, or the nucleophile. Okay, so what does that mean? Remember, your Lewis base attacks the Lewis acid. The arrow goes from the most negative thing from the nucleophile to the most positive thing on the Lewis acid. That's a fundamental understanding of mechanisms and chemical reactions. Okay, so what is the most negative thing on your Lewis base? Well, it's the pi bond. I don't have lone pairs. I don't have anything negative. So I think I told you that if something has a pi bond, your pi bond is going to be the most negative thing. Now, your HCl is your Lewis acid. So I'm looking now for the most positive thing. Well, what's the most positive thing? Well, it's the hydrogen, because the hydrogen has a partial positive. Your chlorine has a partial negative. Okay? So you now know what arrow to draw. You know what electrons are going to start bonding with what atom, based on Chapter 1, Fundamental Rules of General Chemistry. Okay? These electrons are going to go and start forming a bond with hydrogen on one of the carbons. Hydrogen has to form a bond to a carbon. And by doing that, it's going to break these electrons between your HCl. These electrons now are going to go on the chlorine. So what you get, these are what's going to be called intermediates. So this hydrogen now gets attached to the carbon. Doesn't matter which carbon you have. All right, basically it breaks that bond, that double bond. All right, so this electron is going to leave the carbon, and it's going to leave it with a positive charge. Okay, because your carbon only has 6 electrons in it, so it's going to have a positive charge. And your chlorine is hanging out all by itself with its lone pairs. Let me just write in the lone pairs just so we can see where those electrons go. Okay, so that is your intermediate. This is called an intermediate. All right, in particular, this is called a carbocation. We'll talk a lot more about these in a later chapter. So this is the intermediate. Okay, so that's what happens. Those electrons go and grab the hydrogen, you form a carbocation, and the hydrogen gets added onto your molecule. What happens next is your chlorine. I mean, by looking at the final product, you can figure out what happens. The chlorine now is the Lewis base, and it attacks your carbon, which is positively charged, which is your Lewis acid, to now form your final product. So the Cl- is your nucleophile, your C+ is the electrophile. Okay? So this is what a mechanism is. This is how you do mechanisms. You have to figure out what the Lewis base is. You got to figure out what the Lewis acid is. You got to figure out what's the most negative thing, what's the most positive thing. The most negative thing forms a bond to the most positive thing. Okay? So this is kind of what happens. So let's try a practice mechanism. Okay? Now the thing about understanding mechanisms is you might never see a reaction before. You have no idea what the product is. But if you understand how to draw mechanisms, you can figure out what the product is going to be. That's why understanding this is actually a very powerful tool. You might come across a reaction that you have no idea what the product is, but based on this fundamental principle of chemistry, you can figure out what the product is. Okay? So here we have a CH3 with a lone pairs with a negative charge, and you have formaldehyde. Okay? First thing you want to do, figure out what is the nucleophile and what is the electrophile. Number 2, okay, what is the most negative thing? What is the most positive thing? Number 3, draw your arrows. And then 4, based on that, predict what the product is. Okay, so I'm going to put on pause. I guess it doesn't matter if I put on pause, but you put on pause, you give it a try, and when we come back, I will do the problem. All right, I'm going to redraw it up here so I have more room. Okay, so first of all, what is your nucleophile? Your nucleophile is a CH3-. How do I know? It's negatively charged. All right, nucleophiles, if it's a negative charge, that's your nucleophile. So that means this is my electrophile. And remember, the electrophiles are the positive things. So what is the most positive thing on formaldehyde? Well, the most positive thing on this molecule is your carbon. All right, why is your carbon? A lot of people say the hydrogen, but it's not the hydrogen. All right, remember, to determine if something is positive or negative, in this case it's partial positive or negative, you do it based off of electronegativity and bond polarity. We learned that in Chapter 1. We're going to see this over and over and over. This concept you have to understand because we're going to see it a lot. So your carbon is partial positive because your oxygen is more electronegative. Your hydrogens have a neutral charge. So your negative thing, your CH3, is going to go to the most positive thing. So these electrons are going to go and start forming a bond with carbon. Remember, the arrow shows the bonds. Okay? So carbon can only make 4 bonds. So if it makes a bond, it's got to break a bond. Now, is it going to break a CH nonpolar sigma bond? No. Why? First of all, CH is nonpolar. Polarized bonds don't usually break. There's no reason for it to break. Secondly, we learn that sigma bonds are very strong. All right? If it's a nonpolar bond, it's not going to break. So the other option is a polarized pi bond. So let's talk about that. Polarized, okay, your oxygens are already pulling the electrons towards it. The bonds are already breaking. Secondly, pi bond. What do we learn about pi bonds? Pi bonds are weak. So these electrons are going to go to the oxygen. So what's your new molecule? Your new molecule is going to look like this. And you're now going to have an oxygen with one bond on it with these many lone pairs. And we've learned, based on formal charges, that oxygen should have a negative charge now. So that is what you should have gotten from your product based on understanding how to do mechanisms. All right, in class we'll do more practice, but for right now, this is basically the introduction to mechanisms.